Hi, my name is Ryan Hallback, and I'm a Principal Intelligence Analyst at the Vertex Project. In this webinar, I'll demonstrate how we used Synapse to analyze the Contileaks dataset and gain key insights into how the Conti threat group leveraged Bitcoin for their extortion operations. In February of 2022, a Ukrainian researcher with the Twitter handle of Contileaks leaked over 6,000 internal Conti chat messages. These messages contained internal team communications and offered unprecedented access into the group's ransomware operations. It was a firsthand account of how they operated. It provided access to their organizational structure, how they recruited their talent, how they negotiated with their victims, and it even provided access to their cryptocurrency operations and how they used that to access their victims. As a security researcher, we often get access to some common IOCs obtained from a breach. Those would be IOCs like IP addresses and file hashes. But what we wanted to focus on with this data set was cryptocurrency activity. Specifically, we wanted to juxtapose publicly available blockchain transaction data with the team's internal communications. Because not only would this allow us to confirm blockchain activity and easily attribute it to the group, but it would also allow us to easily contextualize what we were seeing occur on the blockchain. In this webinar, I will show you how we use Synapse to ingest and analyze the group's chat messages, extract and enrich Bitcoin addresses that we were able to extract from those messages, analyze blockchain transaction data, and ultimately contextualize their blockchain activity and gain some key insights about previously unreported victims and Bitcoin addresses that they use to facilitate their extortion operations. Contileaks was the Twitter account that the researcher used to share this data. On February 27th, this user sent out a tweet, and this tweet contained a URL to the leaked data. We wanted to represent this data in our system, not just the leaked chat messages, but also the Twitter account to help us reference and track where this data came from. So to do that, we used our Twitter power-up to help us ingest the Twitter account, represent the user and the name, even the sign-up date. We also used our Twitter power-up to ingest the tweets that were sent out by this particular user. Here we see the tweet that was sent out on February 27th by this user. And in the tweet, the URL that was referenced and that was put out by the researcher. From here, we wanted to ingest a tarball or that HTML page that was at the end of this URL. So what we did from here was we used our file parser power-up to pull in the actual file. We pulled in the file, which ended up being an HTML file. And following this chain, that HTML file contained a link to a tarball. This tarball was actually a tarball containing over 300 JSON files. These JSON files are what contain the actual chat messages. So if I sort by time, what you can see is the first date, the first set of chat messages that we have, those come from January 29th of 2021. And if I sort in reverse, I can see that the last set of chat messages came from February 27th of 2022, which is the date that the researcher made the tweet. If I run a strings on one of these chat messages and go to the console, I get a glimpse into what the structure of these messages look like. I can see the timestamp for the message, who the message was sent from and to, and also the body, showing that the body contained things like URLs. While this information is great, as an analyst, I need this information represented structurally so that I can easily analyze the data. So what we wanted to do was transform these messages from their original form into a way that analysts could analyze and easily reason over the data. So what we did was use our ingest tool to ingest the data. We combined all of these JSON files into a single JSON-L file, and we wrote a set of storm code that would allow us to transform the data from just these individual lines into actual web messages. We created web messages for each individual message. We then tagged all of these messages with two tags, one to represent the fact that they came from the Contileaks user and that they were attributed to Conti, and then also that we ourselves were starting a research story with the name of Contileaks. In addition to creating web messages, we created web accounts to represent the users that were observed in the messages. And then lastly, we did two important things. We used our scrape command to extract some easily identifiable indicators like IP addresses and domains from the data set. We tagged all of those extracted indicators with tags as well, and we linked them back to the original web message to help us easily get context for the indicators. And then lastly, because a lot of the messages were in Russian, we needed to translate those to English. So we used our Argos power-up to translate the messages from Russian to English. So going back, what does that data look like? That data now is represented as INET web messages that are stored in the system. Let me pull up a sample. Here are a sample of Conti web messages that we created. Here are the forms. All of these messages are tagged with our story tag. And if I sort, what you get an idea of is some of the conversations that this particular group was having. We go back to 2020, and then we also go up here, at least in this sampling, to 2022. Like I mentioned earlier, we wanted to translate these messages from Russian to English. So we did that using our power-up. And then now we're able to leverage the English text message that is directly on the note to help us easily analyze the data. And what you can see as I scroll down, we have some messages that are encrypted, but other messages that are not. And what we got a glimpse into is how they were operating. We see the usernames, we see the times that they were communicating, so who the messages were sent from and to. And we see that they're having everything from actual business conversations to casual conversations as well. If I click on one of the messages, we can see some of the things that they're talking about specifically and some of the indicators that we can extract, like domain addresses, we can see IP addresses, and even some credentials. So if I scroll back up, select the messages, and pivot over, we get an idea of some of the indicators that we extracted. Here is an example of some of the credentials, some servers, IP addresses, and in this case, we have our cryptocurrency addresses. Like I mentioned at the beginning, we were interested in taking a look at some of their Bitcoin activity. So in order for us to do that, we needed to pull in some blockchain data so that we can juxtapose the blockchain data with some of their own internal messaging. In order to pull in that blockchain data, what we needed to do was leverage a power-up. We have several power-ups that we can use to pull in blockchain data, but the power-up that we used for this analysis was our block cipher power-up. We used our block cipher power-up to pull in the transaction data, and when that data was in the system, then we're able to pivot from the actual address over to the transactions that were pulled in. In Synapse, we represent blockchain activity and transaction data primarily using three forms. First, we have our crypto input form. We use this form to represent any inputs that originated from a particular address. So we represent the values that they put into a particular transaction. We also use our crypto output form. We use this form to represent any outputs that are associated with an address. So any values or any payments that a particular address received. And then lastly, we create an actual crypto transaction node. This is what we use to represent the transaction itself. And for a given transaction, we want to store the time that the transaction occurred, the actual transaction hash, the total value associated with it, the fees, and even things like the block and the block offset, and whether or not it was successful. So going back, for any Bitcoin address that we extracted from this data set, not only did we have the crypto transaction information, but now coupled with that, we actually have the web messages that the crypto actors sent. So going back, how do we approach this data? We want to analyze the data and see what we can figure out about all of the activity that these actors were involved in. We took a couple of approaches to analyzing the data. And one of the approaches we took was just narrowing down web messages that directly referenced a particular address. This helped us easily get context, and it was a good way for us to initially dive into the data. So for an example, if you look at this very first message, this message that was sent on 6/2/2020, we have a message that's being sent from user Rashev to Stern, where Rashev is requesting payment for 2 weeks, and he's requesting that that payment be sent to this Bitcoin address. If we pivot from this message, what we get are the users that are involved in this communication. We get the cryptocurrency address that was extracted, and now we're able to pivot over to the inputs and outputs associated with that address. Looking at the transaction that took place on 6/22, which is the date that the web message was sent by Rochelle to Stern, we can see that a transaction actually took place. We have an amount of 0.074 BTC being sent to this account. This was the account that Rochelle sent to Stern. And if we look over here, we can see roughly the equivalent US dollar value for that Bitcoin amount. We have about 720 US dollars. Not only do we see when that amount was put into this particular transaction and sent to that account, but we also see when that account sent money out in another transaction on 6/25. So what we're able to quickly see here are what transactions a particular address was associated with, and also we have some context. Now, when we go back to this web message, we can use our tags to annotate and reflect our assessment. Here, we added a tag of operational expenses. We identified or assessed that this was associated with payroll maybe, so we added that context to this particular message. As you scroll down, we were able to do this for several messages easily within the data set and apply tags as we came across something important. More operational expenses, but this time we saw, for an example, a crypto address being sent, what looked like it was being sent for servers and maybe some signatures, etc. So this is a great way for us to initially triage the data. But what we wanted to do was take it a step further. We specifically wanted to track and analyze extortion payments. So how could we do that? To do that, we took a different approach. Specifically, what we did was we wanted to look for payments that exceeded a particular value. That value was 15. The reason we chose 15 was because back in 2021, the average ransomware payment was around 500,000 US dollars. 15 is the equivalent in BTC of that amount. So what we did was we lifted all of the addresses that were identified in this data set. We pivoted to their outputs, so where money was sent or when money was sent to that particular address, and then when money was sent that exceeded 15 BTC. What that gave us was about 10 outputs that we could analyze. What was interesting in the result set was that the very first result, one that returned from 2019, was already associated with some previous research that we did, and it was a part of a research story named Stunt Double. Stunt Double was a part of some research, and it came about from some Clear Sky reporting where they associated this address with the Wizard Spider threat actor. Wizard Spider is another name for the Conti threat group. When you look at the transaction that they reported, what they indicated was that they were using this address to consolidate payments. And not only consolidate payments, but what they noticed was some type of pattern where not only Conti malware and ransomware payments were being sent to this address, but also Riot as well. When we pivot from the address, we see the crypto inputs from that address, we see the outputs, and we also have a reference to the web message that the address was extracted from. So going back up to the outputs, we can see where this particular address was sent a payment of 26 BTC. The interesting thing about the outputs for this address is one, the longevity of the address. So we see how long it was in operation. It was in operation from 2017 all the way to 2022. And we also have a varying range of payments that were made, everything from 1 BTC to 26. So this gives an idea of how they're operating and how they're potentially using this account. They could be using this account not only to consolidate victim payments or store victim payments, but maybe also for operational expenses to help facilitate payroll and purchasing infrastructure. And because the majority of the chat messages originated from 2021, we wanted to look at some outputs that were from 2021. So we started with this output that took place on 12/1/2021. Pivoting from this output, what we see are the web messages that provide context as to what this could be related to. These web messages are linked to this message because of a combination of things. One, because this actual address was contained in the web message, but also as we went ahead and did our analysis, if we were able to determine that it was referencing this address in some way, shape, or form, what we did was manually link this particular output to the web message to help us with our context and our analysis. So if I sort by time, what I'm getting an idea of is how this address is potentially being referenced. I have this 1LY address here, and we see it being referenced by a lot of users, and they're referring to it in relation to this organization called HKI. We see them reference HKI, we see them talk about a particular payment of $1 million, and here we hear them talk about or see them mention $1 million in reference to this actual cryptocurrency address. What we then wanted to do is create a story to track our research. So we created a sub-story called Haiku to track our analysis. So if I lift all of the nodes that are associated with this particular research story, what I see is I have close to 100 nodes that we've lumped in, everything from addresses to transactions and all of the web messages. If I sort by time, I can see when their mentioning of HKI first started. They started back on 11/12. They talk about HKI. Not only do they talk about the organization, but they talk about the amount of data that they have, or actually lack thereof, because they only have about 8 gigabytes. Then they mention some of the files that they have on the organization as well, and how much they're requesting for ransom. And as we scroll down, we see them mention the fact that HKI paid on a particular date. If we look at this message on 12/1, we see them mention that there was a payment from HKI. So now what we can do is pivot back up and take a look to see, was a payment made actually to this address on 12/1/21? So if we want to confirm that the payment was actually made on 12/1, all we need to do is go back up to this cryptocurrency address and see if we can identify an output being sent to this address. And in fact, we're able to do so. We can see that on 12/1, that an output was sent to this address, and specifically a value of 19 BTC. If I pivot from this transaction, I can see the total amount that was associated with that transaction. And not only do I get the output, but I also get the input. So I see where this money was sent from. So this was cool because what I was able to do was not only see what this address was being referenced or how it was being referenced within the data set, but I was able to use their own internal messaging to see that, yes, a payment was made to HKI or from HKI on this date. And I was able to compare this message to the actual transaction output. Now, what if I wanted to see where this money went? All I needed to do was pivot from this address again, but this time, instead of going to the output, go to the input. So now I see that on 12/21, this money is now moving in another transaction. If I pivot over to this transaction, what I can see is that a value of 112 BTC was being sent in total as a part of this transaction. And what I get is not only our address being sent, our victim address payment being sent of 19 BTC, but what I also get are other addresses that were used as a part of this transaction as well. What this allowed me to then do was cluster all of these addresses together and identify more Conti addresses that I previously didn't know about. With this, I then created a wallet to reflect the fact that all of these addresses were linked together. And this way we can easily come back to these addresses at a later date and analyze some of their transactions further. So going back to this transaction where we see the money starting to move, what was interesting was this address, because what I see is this BC1Q address being sent a value, a nice round value of 100 BTC. If I follow this address to see what types of transactions this particular address was associated with, I see that on 12/21, not only did our victim payment go into this account, but several other seemingly victim payments went into this account as well. They all appear to be around 100 BTC, which was roughly around 4 million US dollars at that time. When we initially did our analysis back in 2022, the balance was 500 BTC, so the money hadn't moved yet. But earlier this year, that money did in fact start to move. So if we wanted to, we can then follow this money out even further to see where these victim payments were being sent to and what that final account looked like. Where did all of this money end up going? What's interesting about this research was that we were able to identify a consolidation account, another one being used by the Conti threat group. That was our suspicion. That's what we thought. We felt like we identified yet another consolidation account. But to confirm our suspicion, we wanted to go back to our original set of data, or our original seed node to this research, and see if we would be able to determine whether or not another payment was in fact being sent to the same address. So we used this query to find another transaction of interest. So going one transaction up, there was also another transaction on November 23rd, 23 of 2021, where this address, 1KK, was sent another value of 19 BTC. Pivoting from this address, we can see all of the web messages that this address was associated with as well. In this case, if I open up these messages, I can see that this address was referenced by the user Tramp. Here we see that they mention this 1KK address, and they mention it in association with this organization HDP. We see them talk about this organization, and then we see them talk about the amount of information that they have on the organization, and we start to see some of their extortion tactics come out. We see them using a double extortion technique here, where they talk about the personal data that they have on their clients, and how not only do they want to receive payment, but they talk about potentially sharing this data on the dark net. What if we wanted to then follow this transaction to see what happened, and actually see if we can find a transaction in general and see if a victim payment was in fact made? Well, to start this research story, what we did was create a research story, and we named it Ginger Chew. Here you can see all of the indicators that we've lumped together as a part of this research, everything once again from addresses to some of the web messages. And if we sort by time, we can see that actually HKI and HDP were initially listed together. Here we see where HDP occurred, or where their name occurred in their messages in relation to that cryptocurrency address. And then we also see something referenced here on 11/23 where they indicate that HTTP actually paid. If we go back up to this cryptocurrency address and pivot over, we can look at the transaction outputs once again to see that, in fact, on 11/23, a payment was made to this address, and a payment of 19 BTC. What we wanted to see was where this transaction ended up, or where the monies from this transaction ended up going. We were actually able to find and do some pivoting and some enrichment of addresses, and figure out and identify that, in fact, as we suspected, that account that we identified and suspected to be a consolidation account, this money ended up going into that account as well. And to show you what that looks like, what I'll do is I will switch my workspace and switch from tabular view into force graph view. What I did here was I ran a query that lifted all of the nodes that were associated with the story, Ginger Chew, and our Follow the Money research. And I also lifted all of the nodes associated with our haiku research as well, and all of the nodes specifically related to our Follow the Money research there. What that did was yield this graph. And in this graph, what you will notice is that we have some nodes that are different colors. All of the nodes that are in this ginger color, you guessed it, they are associated with our Ginger Chew research. All of the nodes that are in blue, they are associated with haiku. And then this node here that's in like this pink or purplish color, this is that address, that consolidation account that we were interested in researching and confirming. What we saw here was a convergence. We actually saw where the transactions that originated within Ginger Chew, and the transactions that originated within haiku, they all ended up going to this address. So we were actually able to quickly confirm within the same data set that this address that we suspected to be a consolidation account was in fact a consolidation account. During this research, not only were we able to confirm just the fact that this was a consolidation account, but we were able to get a lot of unique insight into their operations and their TTPs. One of the things that we use within Synapse to capture our analysis and assessments, while we do represent some things structurally, we do primarily use tags to capture some of our assessments and help annotate nodes. So if I pivot from all of the cryptocurrency addresses that we extracted within a data set to the tags that we applied, you can see some of the context that we were able to glean, which is pretty impressive. We were able to identify some additional cryptocurrency addresses that weren't previously reported through our own pivoting and clustering. We identified some wallets that we were able to create and link together. We were able to link some of their internal messages and some of these cryptocurrency addresses to some previous reporting that we triaged. And we were able to identify what they were using some of these crypto addresses for, whether it was to help them pay for infrastructure and VPSs, or if it was actually related to victim payments like this HTTP victim or HKI. What I was able to do, starting with just one simple tweet, was programmatically ingest and translate a set of messages and translate those messages from Russian into English. I was able to extract and enrich some Bitcoin addresses and use our block cipher PowerUp to pull in some of that key transaction data. Then I was able to contextualize some of these addresses and gain insight into how they operated, and not only identify extortion payments, but some victims that were previously unreported.